One of the problems with vector databases is that you always need another database to handle your non-vector data. So this could be your text data, text blobs, application data, and you might also need lexical search, which now means that you're juggling 3 systems, and keeping all of this in sync can become a real challenge, especially when it comes to your embeddings. And that's why Timescale argues that vector databases are built on the wrong abstraction. In this article, they introduce a new Vectorizer as part of Pgai that lets you create and sync embeddings straight from Postgres. And I went through the whole setup, testing everything out, and in this video I will walk you through that process to not only show you how you can create automated vector embeddings in PostgreSQL, but also help you understand the kind of like the paradigm shift here, why it's different, for you to then eventually assess whether this could be part of your AI workflow, because I think they're onto something here. And it is really an interesting approach. So in this video, I will walk you through the entire quick start. I'll show you the code examples. I will also make the repository available for you, so you have everything that you need. So let's dive in. So the first step is to come to the repository, link in the description. And I want to let you know that this video is part of a larger series that I'm doing on building RAG systems using Postgres. So I'm a big fan of using a PostgreSQL database for vector embeddings, vector search. And on the branches here, you can see the initial video that I did, the setup, the hybrid search, and now we're diving into Pgai. You don't need to watch the other videos, but it can give you some more context, just so you know. Now, in order to follow along, you need Docker Desktop, a PostgreSQL GUI client, an OpenAI key, and you need Python. So clone the repository. I have it open over here. Let me close this up, and let's quickly fix the .env. So you should be familiar with how this works. There are 2 env files in here. I think that's the only thing that you have to keep in mind. We have one in the app folder and we have one in the Docker folder. So the Docker folder, example.env, switch that to the regular env, plug in your OpenAI API key, and then here in the app folder, same story. The Timescale service URL is already in here. You can leave it default, plug in your OpenAI API key. More on why we're doing that in a bit, but that is the first step. All right, what we can now do is we can come over here to the Docker folder and we can see a Docker compose file in here. So this contains 2 images. We have the Timescale DB PostgreSQL database. So this is going to be your regular PostgreSQL database, but with some Timescale extensions and functionality already embedded in there. So that is the first one, and we'll provide it with the OpenAI API key because this is going to be used by the extensions that we're going to use. And we're going to spin up a Vectorizer worker. So I want to give you some quick context on how this works. Let me scroll down more in the article. But essentially how this whole system works is you create a table in your PostgreSQL database with your regular data. So let's say you're capturing blog posts. So you have one column, blogs, it's a text column, that's in there. Now, what we're going to do is we're going to create an embedding table that you can see over here. So this is the embedding table. And through the worker, every time something changes within the source data table, we're going to trigger the worker to put it into a queue and process the embeddings. So essentially, we're creating this sync between the source data table and the embedding data table, but we're doing it straight from the database. So the logic is embedded in there. So we don't need an additional backend or logic to keep track of that. So that's how this works, and I think that is the new paradigm that they're introducing here. We keep everything in sync from within the database. So that's the Vectorizer worker. So more on how it specifically works when we get to it. But just so you know, this is the other image, and it also requires the OpenAI API key. So with that out of the way, we can come over here and open up our terminal. And let me see, I am already in a Docker folder. So make sure that when you open up this folder over here, you cd into the Docker folder. You can check that everything is in here. And what you can then run is the following command. So we can do the docker compose up to start the Docker container. We'll do it in the detached mode. And the first time that you're running this, it can take a little longer because it's going to download the images first. This is going to start up, and then if everything is configured correctly, which it should be because you download it, clone it straight from the repository, you can see within your Docker desktop that you now have Pgai running over here with 2 services underneath, your database and the worker. All right, so now let's look at what this database setup is doing, because if you come over here to the Docker folder, you can see the plain Docker compose, but we also have a initdb folder in here with some SQL queries. And how this works with Docker, it's going to look into this folder upon startup, and it's going to run these files in the order that they are within the folder. So let's come back over here to see what we're doing. And if you look at the quick start, so again, quick context switch, this is the quick start provided by Timescale. You can see their approach. I essentially started with this Docker compose file and followed the instructions, but they instruct you to do everything in plain SQL, meaning that you connect to your database and then run the SQL commands manually. I don't like doing that manually over and over again, especially if you're configuring things and constantly have to, for example, delete the Docker image because you messed something up. So what I did is I took the setup parts and I put them into SQL scripts that are going to be ran the first time that you boot this up. So the first script over here is to install 2 extensions. So here you can see create extension, and the first one is AI. So this is installing the Pgai. Where is it? This is installing the Pgai extension within Postgres. And the other one is the vector scale. For this tutorial, we don't even need it. You could leave this out, but I put it in here just in case. You can view more about that in my other videos. So then the second one is simply create a new table. For this tutorial, we're going to use a data set of news articles. So we have an ID, an article, highlights, and we're also going to add a summary. So very straightforward. And then the third one, this is an interesting one, because this is how we can create the Vectorizer, and it follows a specific syntax because, as you can see, we're using the AI extension here. Now, I took this example from the quick start. So coming over here. So here you can see explaining how you can create these vectorizers. And there is much more information if you look into the API reference of the Vectorizer. So here you can see how you can create the configurations for everything. But for now, I just want you to know that we're essentially saying we're creating an embedding table. We call it news embedding, and we call it OpenAI small because we're using the small model. And here we're essentially giving some instructions on how to chunk the news articles and then also how to format it. So that's all you need to know for now. So that is what is happening behind the scenes when we boot up this Docker container and create the volume for the first time. All right, so now that everything is up and running, we can already insert the data and then check the results. But let me already pull this up over here and reconnect to the database. So here you can see I'm using table plus, and can I zoom? No, I can't zoom this in right now. You can see everything that we just created. So we have a news table with article and highlight, and we also have a embedding store, similar to how the name that we specified in the SQL script. And we also have a view. So you'll see in a bit what that is doing, but essentially going to take the raw data and the embeddings and put it together in a single view. So that is what you should have right now, but it's still empty. So now what we can do is if you create an environment and install the requirements.txt that are in here, you can come to the app folder and look at the absurd file over here. And what we can do over here, if we load this, we can load this data set. So we use the CNN Daily Mail, and I'm just going to select 10 of the articles for now. So we have the subset and we can put it into a data frame. And now over here, you can see what it looks like, an article and the highlights. So just 10 simple articles, not too much. And now next, what we can do over here is we can add some context in the form of a summary. So I'm just going to run this. You can look into the Summaries, what it's doing over here, but this is inspired by contextual retrieval from Anthropic, but in a slightly different way because we're not creating the chunks first, but we're just adding some context because these articles are relatively long. We're adding a summary column so that when we are later chunking, we can use that summary to attach to every chunk. So let me show what it looks like. So now if we look into the data frame, we can see the article, we have the highlight, and we have a, 1 or 2 sentence summary. And now next, here is a bunch of code that allows us to store this into the database. So you can see insert into news article. So here's your SQL query. So again, remember, if you start to tweak with things, make sure you update these column names and then also correctly map the values. And this is essentially it's making a connection via the database service URL, which is just loading the timescale service URL from the environment variable. I'm using a settings.py file over here. It's not needed for this. It's just how I like to structure my settings. And I did that in the previous tutorial. So now with everything in here, this should be instant and we can come back to our database over here and let me refresh this. And now we can see ID, article, highlights, summary, 10 articles. Beautiful. But now let's look over here. Now what we can see here is still an empty embeddings table. But let me show you what is happening now behind the scenes. Because if I now open up a new SQL query over here and I run this, so this is the AI.Vectorizer status, we can see that there are 10 pending items. Now quickly coming back to the context over here, this worker that is running behind the scenes. So let me show you this worker that is running. It is essentially, the default settings are to run and process this every 5 minutes. So every 5 minutes, it will look into your source data table. And then if there are any changes, it will process that and sync it with the embedding table. And it can do all of that because we plugged in our OpenAI API key. And we also specified, remember over here in the init, which model to use. So embedding OpenAI, text 3 small, and it has the API key. So it has all the context that it needs in order to run this. So now if this were a system that was in production, what we could either do is wait. So then 5 minutes will go by and then this will start to process. But one thing that I've found that also works is stopping just the Vectorizer worker. And then what we can do is we can just run that command again. So come over here, make sure we're in the Docker and just run the Docker compose up, but then only specify the Vectorizer worker. And that is because we've named that image like this. And if I run this, it will boot that up again. This should be here. And now if we come back to the overview and we reload this, this should get to 0. So now all of the items that were in the queue have been processed. And now here's the cool thing. Now we can open the embedding store and we can see all of our embeddings in here. So let me visually show you what that looks like. Here we have an embedding ID 6, we have a chunk sequence, we have the chunk itself. So here you can see it first has the summary and then the chunk that it identified and then also the embedding. And the ID is now linking back to the ID within your original data table, and the view that they created brings all of this together. So here we can see the embedding UID, we can see the chunk, we can see the actual chunk, and also then if we scroll down a little, we can see the highlights, the summary, and we have the whole context of everything that we need to now start performing similarity search on this. So by now I think you should get the picture and should start to see how this is pretty much a paradigm shift in how to manage and create and keep your vectors in sync. And like I've said, I think they're onto something here. I really like this approach and it could tackle a lot of the problems and issues that we've ran into in the past. And what I also like that everything is here available within the AI schema. So you can look at your vectorizers over here, you can see the error logs, and all of your settings are stored here in the schema as well. So now that this is in place, performing similarity searches is pretty straightforward. So we can come to the, let me close this up, to the search.py. So here we have the search. Let me show you, you can see this, yeah. Let's boot this up. We have the semantic search. So what we can now do here is we have another function to interact with our database and to execute a SQL command. And we're going to select the UUID and the chunk from our news embedding OpenAI small. So remember, we're using the view over here. So that's the table we're querying on. And we're going to order by the embedding. And here's the cool thing. Look at this. We can now say select AI, OpenAI embed, and specify the name of the model here. So not only do we abstract the embedding logic upon creation to the backend in our database, we also abstract that same logic to the search. And for those of you that are new to performing similarity search with Postgres, this is the cosine similarity that we're using over here as a metric. And we can come in here and what we can now do is we have a question, is there any news about London? And we can run this search and it will take some time, and there we go. And this semantic search that we're doing over here, you can see we have the limit specified to 15. So this is going to get 15 results from the database. So that's how you can perform RAG with this system. You specify your SQL query, and the embeddings are taken care of by the database and the extension running on it. And we also have a synthesizer in here, which now essentially allows us to generate a response. So you can look into the code base at what this is doing, but this is not really the scope of this video. So just sending it to OpenAI with the information and the query, and you can see the news related to etc. It's going to give a summary. So simple prompt behind that, nothing too crazy. Now, and one thing that I still have to look into is, as you can see right now here, we're using plain SQL to do the similarity search. And for people that have watched my previous tutorials on RAG with Postgres, you might remember that we were using the Timescale vector library. So it's a pip install Timescale vector, and with this we could do similarity search, hybrid search, metadata filtering, time-based search, all of that from a Python client. Now, I scrolled all the way down to the README over here, and you can see that Timescale is already making some documentation here. So there are some ways to already work with this, but I haven't figured it out completely yet. So just so you know, if you followed the other tutorials and you're now seeing like, hey, but now the whole vector class that we created doesn't work with this, I still have to see how those two fit together. But I believe they're working on it, so there's information over here, so that would be a cool addition for a future video maybe. So here, what we did, the AI extension create vectorizes, it sets up the automatic embedding based on your table. Then when you insert update, the worker detects these changes and it's going to put it in the queue. Worker automatically generates the embeddings, in this case using OpenAI. Embeddings are stored in a separate table, kept in sync. And we can now perform similarity search on this with this operator, again, cosine distance. And this entirely eliminates the need to manage the embeddings within your application code. And now, while I think the major benefit here is keeping everything in sync, another really interesting thing that you can now do is compare different embedding models, but very easily. So let me show you what it now looks like if we were to compare OpenAI embeddings small with large. I have some example code here in the README as well, and let me now come back to my database and run this command. So we have the same news table, everything is the same, but we are now using the text embedding 3 large, and also we specify the dimension for that model, the API key, but it's exactly the same, just a different model. We run that, we execute that. Now let's see what happens if I refresh this table. We have one new table and one new view. So this is now also still empty, but let me come to the status over here. You can now see that because we created this on the news table, we also have 10 embeddings waiting within the line. So let me do this trick again to force this one more time. Let me see, start this up, do the vectorizer, run this one more time. All right, let's see. All right, there we go. And now we also have the large embeddings in here. And now look at what we can do. So now if I come back to my application code over here and let's see, I can now literally just change this into large and then also change this into large. And this should now work. Oh, if I run it correctly. And there we go. And now we have a result using text embedding 3 large. So see how that was literally like 20 seconds to set this up. So now I changed this. So what you ideally should do is of course run experiments. So what you will do is you would set up a different one, get clear on some metrics like recall, groundedness, correctedness, and then do a test to really see, okay, what's the difference here between, for example, migrating from ADA to text embedding 3 small, or difference between small and large, or maybe check an embedding model from Anthropic or Cohere. And run these tests side by side. And of course, it's nothing new. It's also something you can do in your application code. But having everything here within your database, coming back over here, and just having these separate tables and also keeping everything in sync. So now if I come over here and I add something, so I could, for example, come in here and let's see, let's just do 11 and do test, whatever, test. Maybe add this in here as well. So now if I come back to the Vectorizer, so here you can now see that both of them have one new item in line. So by setting up that Vectorizer once, we keep everything in sync. So that's really the cool thing here as well. Not only keeping your main embedding models in sync, but also being able to do and run experiments in parallel, because ultimately that is long-term for your AI applications is going to be one of the key success factors, is whether you can create, continue and monitor enough experiments with everything that is going on. So that's how you automate vector embeddings in Postgres using Pgai. So I'm really curious to hear your take and your opinion on this. Is this something that would fit well for the type of projects that you are working on? Because I think for us, it definitely makes sense. I'm not sure if we can immediately migrate all of this, but I'm definitely going to run some projects in parallel to see if we can really migrate to all of this, because we are already within PostgreSQL database doing everything there, but now just managing our embeddings within our Python application. And this could really further streamline our development workflow for this. And that is something that we at Datalumina are always looking for, because being an AI development agency, we're working with lots of projects, lots of clients. So we're always trying to find and optimize things and make things more manageable at scale. So that's it for this video. Thank you for watching. And now, by the way, if you want to learn more about how we help developers like you beyond these YouTube videos, you can check out the links in the descriptions. One is to our recently launched Generative AI Launchpad. This is for you if you want to build and deploy Gen AI apps faster. But we also help data professionals to get started with freelancing. So if you're a developer and you've been thinking about the idea of starting your own thing, becoming an independent contractor, but you don't really know where to start or how to land that first client, again, you might want to check out the first link in the description. There's a video of me going over how Datalumina, my company, can help you with this. Now, of course, as with both of these pitches over here, these are funnels designed to get leads for our company. So just so you know that, all transparency, if you're just here for YouTube and the videos, that's okay. But if you want to see how we work with other developers, go check those out. And then I want to thank you as always for watching. I'll see you in the next one, and make sure to check out these videos here next. This is the series that I was talking about how to get the most out of PostgreSQL databases when you're building RAG systems.